These are the frequently asked questions for Algebra 2 for Section 13.2, Day 1. I'm going to start with number 3 here. And number 3 says we're going to use the given information to find the missing side lengths in each 45, 45, 90 triangle. So I always like to do these visually and get a peek at what I have. So they're giving me the square root of 3 feet as my hypotenuse. And then you either sing the song or you think about the relationship inside a 45, 45, 90 triangle and you realize always isosceles, so the two legs are the same length. And then to get to the hypotenuse, you have to multiply by the square root of 2. So for number 3, I need one of those legs. To get to the square root of 3, I had to multiply by the square root of 2. So to work my way back, I'm going to have to do the inverse, which would be to divide by the square root of 2. And as it's set up there, if we need to rationalize denominators, then we have to do that, and that's what's going on here. We can't leave that square root of 2 in the denominator. So we're going to go ahead and multiply the numerator and denominator by the square root of 2, and that will give us the square root of 6 over the square root of 4, and then of course we know that the square root of 4 is just 2. And that's as simplified as we can get because we don't have any perfect squares that are going to divide evenly into that square root of 6. So that 45, 45, 90 triangle, always using that x, and x square roots of 2 relationship that we have in there. And this was in feet. All right, now I'm going to start with number 8 over here to talk about the 30, 60, 90, because this says we're going to use this given information for the 30, 60, 90 triangle, and we still have to rationalize any denominators if we have them. So I draw my little 30, 60, 90 triangle, and I have the shorter leg as the square root of 3. And you either sing the song or remember that whatever we have for the short side, we multiply that by 2 for the hypotenuse, and then we multiply whatever the short side is by the square root of 3 in order to get the longer leg. So what I'm looking for in this one is I'm looking for the longer leg. I go back to my generic triangle here and realize I have to multiply by the square root of 3. So that'll be the square root of 3 times the square root of 3, which is the square root of 9, or you can think of it as the square root of 3 squared. So that will just get us 3. And that will be in centimeters. And then the hypotenuse, to go from short side to the hypotenuse, we need to know that relationship, and that's multiplying by 2. So that'll be 2 times the square root of 3, which is just 2 square roots of 3 centimeters for that one. So when you get the short side, that will go very, very quickly for the 30, 60, 90 triangles, because again, the relationship there is short side multiply times the square root of 3 to get the long side, and multiply by 2 to get the hypotenuse. Now this section, as we talked about in class, this little piece here, very important for what we needed to do in the next problems. Number 8, find the measure of each angle in standard position. And what we have to do is think of forming that right triangle. And usually I'll form that with the x-axis so I can visualize what's going on. And then I see it was -5, -5. And that tells me that has to be an isosceles right triangle. The only way that that's an isosceles right triangle is if this little angle right here is 45 degrees. So a couple of different ways to do it. You could think, okay, well, a straight line's 180 all the way across, so I'll just subtract my little 45 here, and that will get me 135 degrees. And then notice, hey, this is going clockwise, so I need to tack a negative in front of it. Or you could say, all right, so 45 degrees, huh? Well, that means this one's 45 degrees, and then you can take 90 plus 45, you're still going to get 135 degrees. And again, you'd have to notice that this one was going clockwise so that you would put a negative in front of it. Now we go down to number 10. Let's look at 10 first. 10 has the negative square root of 3 over 2, and then 1/2. and this is pretty teeny right here, but this is going to be the square root of 3 over 2, and then this would be 1/2. Now I recognize that square root of 3 from our 30, 60, 90. So we take a look at the 30, 60, 90 and we try to figure out, is this a 30-degree angle or a 60-degree angle that we're looking for right in that position? So let's see what we have. This is always going to be 1, square root of 3, and 2. And you can put your x's in there if you want to. As we write our fractions here, it's not going to make any difference. And then what we have to do is figure out, all right, so what are we talking about here? How did this get to be the square root of 3 over 2? And how did the opposite one get to be 1/2? How did that realize itself? Well, a couple of different things you could do. You could look at this and say, all right, here's my angle. This is opposite and this is adjacent. So I would need the tangent of whatever angle it is to be 1/2 divided by the square root of 3 over 2. Well, we don't divide fractions, we multiply by the reciprocal, so we would take 1/2 and multiply that by 2 over the square root of 3. The 2's are going to cancel out and we'll get 1 over the square root of 3. And you have to keep in mind that this was tangent. So then you look below at the triangle and figure out which one of those angles would have opposite as 1 and adjacent as the square root of 3. So opposite as 1 and adjacent as the square root of 3. That's going to be a 30-degree angle right there. So that's a 30-degree angle, but we wanted this one. I want to figure out what that is. So what we'd have to do is take 180 and subtract the 30, and that would give us a 150-degree angle for number 10. And like I said, that's one way to go through and do it. Otherwise, you can remember what they mentioned about x and y as being your cosine and your sine. So if you remember that, you could go after this a different way and say, all right, well, we've got cosine x and sine x, and do your division that way and then look at tangent. Or again, there's lots of different ways that I can think of to go after this one. It's up to you. Whatever's easiest for you to figure out how you're going to get those measurements, do that when you go through there. Number 11. Number 11, we see that this one has 2 square roots of 3 and a negative 2. And that again makes you realize, hey, this must be either a 30, 60, 90 or a 45, 45, 90. And this one I'm going to draw sideways this time. What's really important is that you make sure that you get those labels on there properly. No matter which way you draw it, which way you turn your triangle, that's what you want to see. Now again, I'm not certain that's the 30 and 60 that we have from this drawing. It's the math that's going to help me do that. So I realized that this was 2 square roots of 3, and then this was your negative 2 because you had to go down 2 to go through that. And again, I think in terms of SOHCAHTOA, so I look at this and I think, well, that's opposite and adjacent again. So the tangent is going to be negative 2 over 2 square roots of 3, and that would give me negative 1 over the square root of 3. So what I'm trying to find is the angle that would have the tangent as 1 over the square root of 3. In quadrant 4, it's going to be negative. But what I want to do is think, okay, if I'm at 60 degrees and I need opposite over adjacent, that's going to be the square root of 3 over 1. So it's not the 60-degree angle. Here's the 30-degree angle. 1 over the square root of 3, opposite over adjacent. So that tangent is for a 30-degree angle, which means this little angle right here is 30 degrees. Now this one is going downward in a clockwise direction, so that would be a negative 30 degrees. So ways to put that SOHCAHTOA back together with what we see up here that will work, that will help you figure out what you have for those angles every time. And I think that's all I'm going to do from that group. Now let me go to the next page. And number 14 is just sketch each angle in standard position. So something to notice here, we still need that Cartesian coordinate plane with the x and the y. Negative 130 is telling us to go clockwise, so I think, hey, there's 90 degrees. How much further would I need to go to get to 130? Well, I'd need 40 degrees. So I'm going to put 40 degrees there, just because I'm not using a protractor and this is just a sketch. But overall, I want to put that negative 130 degrees here, so everybody sees this was clockwise, and it is negative 130 degrees. Number 17, just graphing 95 degrees. Again, thinking, hey, that's positive, so this time I need to go counterclockwise. So I'm going to have to go 90, and then I'm going to have to go another 5 degrees. And I'm just going to try and squish that number in there to show that that was 5 degrees. And that is 95. Now the arrow that you see in this position, that is very important because that gives direction to your angle. So don't forget to put those angles in there.